very important characteristic of carbon compounds is whether they are saturated or unsaturated. That is, whether they have all single bonds or whether there are some double or triple bonds. We are going to test this by reaction with bromine dissolved in water. Unsaturated compounds react with bromine. We are going to use hexane, which is a saturated compound, meaning it has all single bonds in it. Then we will use cyclohexane, which has one double bond, making it unsaturated. And we will use one heptine, which has a triple bond in it, so it is also unsaturated. Then we'll test a commercial product sold as polyunsaturated oil. Polyunsaturated means it has many unsaturated bonds, or double bonds, and we will see whether it reacts with bromine in the same way as our known unsaturated compounds. We're going to do this test by setting up 5 test tubes, each with 2 milliliters of carbon tetrachloride, which is a strong solvent to dissolve the hydrocarbons. To our first test tube, we'll add 20 drops of bromine water and let it be a reference. We give it a shake to dissolve the bromine and just confirm that there is no reaction. To our second tube, we'll add 10 drops of hexane. It dissolves in carbon tetrachloride. Give it a shake, and now we'll add 20 drops of bromine water. Shake it again. Comparing that one with our reference, we see that there is no reaction. The same bromine color exists in the carbon tetrachloride layer. As we see here, the hexane is fully saturated and is completely bonded by hydrogen atoms. Bromine has nowhere it can readily react. 10 drops of cyclohexene have been added, and we shake to dissolve it. Now we'll add 20 drops of bromine. We give this a shake to see if the compounds react. We see that this one has gone colorless. The cyclohexene has reacted with bromine and taken away the color. What has happened is that the cyclohexene with the double bond is unsaturated. The bromine is able to react by breaking the double bond and forms 1,2-dibromocyclohexane. Next, 10 drops of 1-heptine have been added to carbon tetrachloride and dissolved. 20 drops of bromine are added. We need to shake this one a little longer, because although it seems to be reacting, it is a bit slower than the hexene. Again, we notice that the bromine has been completely decolorized in the reaction with the 1-heptine. The triply bonded 1-heptine reacts with bromine to form 1,2-dibromoheptene and continues substituting to form 1,1,2,2-tetrabromoheptane. Finally, we have added 10 drops of polyunsaturated oil, and we need to shake this vigorously. It remains slightly turbid because it is not fully soluble in the carbon tetrachloride. Now we'll add about 20 drops of bromine water to that. Give this a good shake, and again the bromine water is completely decolorized. Bromine reacts with the oil, showing that it is unsaturated. So as we have seen, bromine is a useful reagent for determining saturated and unsaturated compounds. We used our reference of carbon tetrachloride with bromine water to show alkanes are saturated because there is no reaction. Then alkenes and cycloalkenes, alkynes, and finally our vegetable oil were all confirmed as being unsaturated.